Haryana. We are discussing on the topic of water supply and wastewater engineering. Today it's our subject and we are discussing all the detailing briefly. We are starting our course of water supply, how we will treat it, how we can make it, our water, how we will purify it. This process is we study in this water supply and wastewater engineering. So let's start. Today we are here discussing on the topic. So let's start now. Mainly we are having different kind of wastewater which we see in our locality, in our area. We have different kind of wastewater. In this water supply, our system is based on like as wastewater which are spread in our locality or our area. We are performing in this subject like how to perform and how to treatment of wastewater. So let's start now. For the introductions, we have absolutely pure water is never found in nature, but the water found in nature contains number of impurities in varying amount. The rainwater, which is originally pure, also absorbs various gases, dust, and other impurities while filling. We have different kinds of product, solid waste, liquid waste, and gaseous type of dust particles and impurities which are spread in our locality. This water, when moved to the ground, further carries silt, organic and inorganic impurities. The water which are spread in our locality, it is mixed with other types of organic compounds such as silt, organic and inorganic impurities. We have how we will define it. We have said that wholesome water is defined as the water which contains the material in small quantity at requisite level and free from harmful impurities. The water that is fit for drinking, safe and agreeable is called potable waters. The potable water we have to say which is we carry from underground or which we carry from port or well, which is fit for drinking, washing and other purposes. We have to say it is a potable water. It is drinkable and it is safe for it is no harmful effect. If water capabilities, we have to check by the pH. pH is the power of hydration. pH is taken as 7. When it is up and down, our water will start unsafe for our drinking and other purposes. The following are the requirements of wholesome water. It should be free from bacteria, colorless and sparkling. It is tasty, odor, free from and other colds. It should be free from objectionable matters. It should not corrode pipes. It should have dissolved oxygen and free from carbonic acid, so it may remain fresh. If it is corroded by pipes, objectionable matter is present in them, and tasty odor it is free from and not is cool, colorless, odorless, sparkling is present in them, bacteria is present in them, it is harmful for our life, it is not fit for drinking. So, for the water, it is also necessary a dissolved oxygen is present in them. You are looking at a fish. A fish is living in the water, but how it live in the water? Because due to the presence of oxygen is present in them. That's why a whole and fisheries life be present in the water. If there is absence of oxygen in the water, it does not sustain life. It starts dying. We have different sources of water. First is surface source and second is subsurface source. From the subsurface source we have such as rivers, lakes, ponds and impound reservoirs we have, and we are discussing on the subsurface surface. First one is the springs, wells, infiltration galleries, and other form is artesian wells, duct wells, tube wells, infiltration wells. We have different types of source of water. First one is the surface source and second one is the subsurface source. We have taken different types of sources. We have discussed in simple amount. If we have such as rivers, lakes and ponds, other structures we present, we have to say the source and it is in purity form. Such as in the subsurface sources we have to discuss. First one is the artesian wells, duct wells, tube wells, infiltration wells, and we have discussed tube wells. It's a shallow and deep well. If it is in the amount of 3 feet to 4 feet, we have to say it's a shallow wells. But when our wells is 10 feet, 20 feet to 100 feet, we have to say it's a deep well. Shallow wells is approximately 4 to 5 feet. But in deep wells, as in deep foundation, it is from 10 feet to 100 feet. It's all our intake work. We have not construct from the outside. We are study on the intake structure of the earth. First one is the how we perform the intake work is from treatment work. First one is the plain sedimentation. Second one is the sedimentation with coagulations. Third one is the filtration, disinfection, miscellaneous treatment. These are the treatment of water which we do in fields or other system when our water is not fit for drinking, not fit for other purposes, not fit for washings, not fit for sustain life or birth. We have to do a treatment of work. First one is the plain sedimentation. Second one is the sedimentation with coagulations. Third one is the filtration. Fourth one is the disinfections. Fifth one is the miscellaneous treatment. And in the plain sedimentation or miscellaneous treatment, we have a distribution system. In distribution systems, first one is the pumping system. We have to pump and provide water from one surface to another. And first one is the gravity system and other is the DO system. In pumping system, there is a district water main which is branch and service pipe. Third one is the consumer and we have to take wastewater. How wastewater is performed? How the wastewater is formed? It is responsible for our human life. Generally, we are the responsible for the wastewater. If we are not do anything with the water, it's a safe and is perfectly usable. But in our household purposes or other purposes, nowadays wastewater is more increasing day by day. We have also know that only 2.4% water is present for the drinking purposes. But what we do, we are wasting water day by day so that the drinking qualities is become decreases. How we will use for the drinking, how we will sustain life, how we use the water perfectly, we will study in this water supply and wastewater engineering. So first of all, we have discussed the source of water. All the source of water can be broadly divided into first one is the surface source, second one is the subsurface source. First one you see it's a surface source which is stream, rivers, ponds, lakes, impounding reservoir which are present only in the locality which are upon the surface. We have to say it is a surface source. but which is subsurface source is further divided into different types. First one is the infiltration galleries, infiltration wells. Third one is the spring, etc. We have a different kind of subsurface sources. Infiltration, like as we see in the picture, infiltration galleries is a wall, water tables, it's a ground structure. Water is here. We have foundation. By the excavation, we have take water from these areas, or we have this water is poured from this rivers or streams. Water is present in them. Force drainage pipe here. Foundation is here. BK walls, infiltration gallery here. We have provided RCC slabs, water tables. Water flow from this surface to this surface. And third one is the infiltration well. Infiltration well, in this type, a sand bed is here. Like as we will take the example of well. It's a water table, it's a ground, manhole is here, top cover we have provided. If a man carry a water, he put on bucket in it and take water, use for the drinking purpose. It's all are present here. This layer is not be applicable. It's an open surface. Sand bed is here. We will not provide wall here. It's open. All waters are comes from this surface and lay down this surface. Manhole is here, top cover is here. Sandy river bed we have to see. Okay. Third one is the spring, etc. In this spring regions, all the well, like here, all the waters are coming from outside to inside. Like as this wall is here, all the water is coming from outside this surface. Suppose this is a ground surface, all the water comes here, and stay here. We have to take it from this surface, from here. It's a depend on the springs, depend on the season. Water is applicable here, and the levels of water is increasing or decreasing day by day. It will depend on the rainy seasons or the foundation or the water present here. As we have the example of few wells, it's a previous layer, impervious layer. We are divided in two categories. P is the previous layer, impervious layer, previous layer, previous layer, previous layer. We have divided different types of. If you let, there is a board in which motor is provided. First one is strainer. It is a blind pipe. Strainer. It's a blind pipe. It's an empty here. Bottom is the board. Okay. This is structure or drawing the important for your exam. Students, note down this point and please be careful. Draw this neat and clean diagrams in your exam. First one is the type of intake structure. Depending on the source of water, the intake are classified as following. First one is the lake intake. Second one is the reservoir intake. Third one is the river intake. Fourth one is the canal intake. Intake is a type of structure in which we take the water from outside or other materials, other kind of situation, which is said to be intake. First one is a lake intake. We have take water from lake intake. We have take water from reservoir. We have take water from river. We have take water from canal. There is a different types of intake structure. We will take water from those surface. Then we have discussed the water demands. While designing the water supply scheme for a town or a city, it is necessary to determine the total quantity of water required for various purposes by the city. When we are discussing the whole water demand, suppose we have a village. We have divided this village in 5 groups, in 5 blocks. There is maximum take 50 acres in areas. We have to provide water systems in it. We provide bores, filling, and we have to cover all the village. So this equation is based on the designing of water. Second one is as a matter of fact, the first duty of the engineer is to determine the water demand of the town. Water is provided to determine the water demands of town and finding suitable water source from where the demand can be met. Third one is, but as there are so many factors involved in demand of water, it is not possible to accurately determine the actual demand. We have calculated the proper, not exactly the correct demand, but we have to do approximately demand. We have to take approximately it's a 1000, 3000, 4000 liter, 7000 liter, 8000 liter. For the different types of demand, we will study how our demand is there and how we complete the demand of water. There is a lower amount of water, like we have to say 2.4% is available for drinking, but we have used it again and again. How we use it and how we purify it, we will study in the water supply and wastewater engineering. First one is the type of water demand. First one is the domestic water demand, industrial demand, commercial demand, demand for public use, fire demand, losses and waste. When we are discussing on the domestic water demand, first the thought we came to our mind how and which amount of water we use for the domestic purpose. First one is the bathing, toilet flushing, washing of clothes, washing of the house, washing utensils, cooking, drinking. For the bathing purpose, amount of water uses 55 liters. For toilet flushing, we use 30 liters. Washing of clothes, we use 20 liters. And washing the utensils, it is 10 liters. And cooking purpose, we use 5 liters. And for the drinking purpose, we use only 5 liters in per day amount. It is a total per day amount of water which we use for the domestic purpose. Almost 120 liters per day we use water. Other is a fire demand. Suppose during the fire breakdown, large quantity of water is required for throwing it over the fire to extinguish it. Therefore, provision is made in the water work to supply sufficient quantity of water or keep as reserve in the water main for the purpose. In the city, fire hydrants are provided on the water mains at 100 to 150 meter apart for fire demand. The quantity of water required for fighting is generally calculated by using differential equation formula. We have the formulas of Q is equal to 3182 P, for where Q is the quantity of water required in liter per minute, P is the population of town or city in thousands. For finding the per capita demand, we have the formula. Q is the total quantity of water required for various purposes by a town per year, and P is the population of town. Then per capita demand will be equal to Q by P into 365 days liter per day. Q is a discharge, P is a population, and 365 is the total year. Total year in days is the total days. We have calculated it. Okay, suppose Q is the quantity. We have taken it a 50,000 liter, or population is approximately we have 4,000. Multiply it. We have given a values and find out the values. we have reached 4562.5 liter, 4652 liter per day water is consumed by a locality or area. It's approximately for fire demand, domestic purpose 135 liter per day, industrial use 40 liter per day, for public use it's 25 liter per day, and fire demand it's 15 liter per day. For the losses, wastage and theft it's 55 liter per day, and we are discussing on the total it's 270 liter per capital demand per day according to. Okay, when we are discussing about the factor affecting per capital demand, how we will affect it and how will it I calculate it that it's affecting our locality. First, we are discussing on the climate conditions. Second one is the size of community. Third one is the living standard of the people. Fourth one is the industrial and commercial activity. Fifth one is the pressure in the distribution system. Sixth one is the system of sanitation. And last one is the cost of water. This all are factors independent on the affecting per capital demand, or it is affect our water demand. So we are taking or discussing this type of demand. Okay, students, for the next lecture we are discussing on the population forecasting method. So be ready for it. We are discussing on next lecture how our populations be divided or used for the populations forecasting method. We are discussing briefly and completely detailed manner, and we have analyzed the proper wastage and how we will treat the wastewater. So nice to meet you. Meet in the next lecture. Thank you all of you.